There is a photograph taken in 1945 inside a captured German tank factory that explains the Second World War better than most things written about it. In the foreground of the photograph sits an unfinished Panther tank. Behind it, a row of similar hulls. Around them, in scattered groups, men in coveralls. Allied intelligence officers walking the floor with notebooks are recording what they see. What they record is a paradox. The tank is beautiful. The factory is not. The Panther was, by general agreement of every post-war military analyst who studied it, a better tank than the American M4 Sherman that it had spent the last 2 years killing. Better gun, better armor, better optics, better suspension. The trouble was that the Panther factory could not build them fast enough to matter. The Sherman factory, 3,000 miles away in Warren, Michigan, was, in a single record-setting month, December 1942, producing 907 tanks. The Panther's highest monthly production target was 600 per month and was never reached. This is a story you have heard before in one form or another. The Germans built better tanks, the Americans built more of them. Quantity defeated quality. There is even a famous Soviet aphorism, often attributed to Stalin, that quantity has a quality all its own. What that story leaves out, what almost every popular account of the Industrial War leaves out, is the specific machine that allowed the Americans to build more. The reason the Detroit Arsenal tank plant could produce 1 Sherman every several hours, while Henschel and Sohn in Kassel could not produce more than 3 Tigers per day at peak, was not patriotism. It was not industrial spirit. It was not even, in the simple sense, that America had more workers. It was that America had more machine tools, of certain specific types, in certain ratios that mattered enormously for the production of armored fighting vehicles. And of those specific machine tools, none mattered more than one whose name almost no one outside the metalworking industry has ever heard: the Broaching machine. When German engineers compared captured American manufacturing data after the war, they found that the United States operated roughly 5 times more broaching machines per metalworking employee than Germany did. That ratio, 5 to 1, is the kind of fact that does not appear in popular histories of the Second World War, but it explains, more precisely than any tactical account, why the war ended the way it did. This is the story of that machine and the war it quietly decided. To understand why broaching machines mattered, you have to understand what a tank actually is, as an industrial object. A medium tank in 1942 was approximately 30 tons of welded steel armor wrapped around an internal combustion engine, a transmission, a suspension system, a turret with a gun, a recoil mechanism, and roughly 30,000 individual mechanical parts. Many of those parts were precision-machined steel components: gears, splines, internal teeth, keyways, complex internal contours that had to be cut to tolerances measured in thousandths of an inch. A gear that was off by 5,000ths of an inch would either fail to mesh or mesh badly and tear itself apart under load. A spline cut imprecisely would slip under torque. A keyway off-center would shear under stress. A turret race that was not perfectly circular would jam at exactly the moment the gunner needed to track a moving target. These were not casual machining problems. They were the heart of the entire industrial proposition. Whoever could cut precision internal features into steel components faster, more consistently, and with less skilled labor, that was who could build tanks at scale. The conventional machining techniques available in the 1930s were milling, turning, drilling, and grinding. Each had its place. None of them was particularly fast at producing the kinds of internal features that a tank's transmission and turret required. To cut an internal spline by milling required multiple passes of a small cutter, each pass removing a thin layer of metal, often with the work reclamped between passes to access a different angle. A skilled machinist could produce a finished internal spline in perhaps 45 minutes to an hour, sometimes longer for complex profiles. Across the thousands of such features in a single tank's gearbox, transmission, and turret race, the total machining time per vehicle was enormous, and every minute of it required a trained operator. This was the bottleneck, not the steel, not the engine design, not the gun. The bottleneck was the time it took to cut the precision internal features that made the steel pieces work together as a machine. In 1939, when Germany invaded Poland with a panzer force that had been quietly built up over 6 years of intensive rearmament, this bottleneck was hidden. German tanks were good, their internal precision was excellent, their crews were trained. What no one yet understood was that the bottleneck would matter more, not less, as the war went on. As tank designs grew more complex, Tiger, Panther, King Tiger, with their heavier guns and more elaborate transmissions, the machining requirements grew with them. By 1943, the German tank industry was caught in a vice. The tanks they needed to build were more demanding to machine than ever, and the labor pool capable of doing the demanding machining was shrinking. The American industry, working on the same physical problem with the same physical materials, was about to demonstrate that it had a different answer. The broaching machine is not glamorous. It is not, on first inspection, even particularly impressive. In a typical 1940s configuration, it consists of a vertical or horizontal frame, a hydraulic ram, and a long-toothed cutting tool, the broach itself, that resembles a steel rod with rows of progressively larger teeth running along its length. The workpiece is clamped in a fixture. The broach is either pushed or pulled through it. The teeth, each slightly larger than the one before, peel away thin layers of metal in a single linear pass. The first teeth do rough cutting. The middle teeth do bulk removal. The final teeth do precision finishing. The result is a finished internal feature, a spline, a keyway, an internal gear profile, a polygonal hole, produced in a single pass of the tool, in seconds rather than minutes, with no need to reclamp the workpiece, no need for multiple passes, no need for the operator to make judgment calls on feed rate or cutter selection. The geometric precision of the finished feature is entirely determined by the precision of the broach tool itself. As long as the broach is sharp and the machine is properly aligned, the part comes out the same way every time. The implications of this were enormous, and they ran in 3 directions at once. The first direction was speed. A feature that would take an experienced milling operator 45 minutes could be broached in 20 to 30 seconds. For typical keyway machining, broaching took 10 to 30 seconds, where milling took several minutes. For internal splines and gear teeth, the kinds of features densely packed into a tank transmission, the speed advantage was even larger. A broaching machine could produce a finished gear rack every 40 seconds while maintaining tolerances of 0.5 of an inch. The second direction was consistency. A milling operation depends on the skill of the operator, the speeds and feeds, the depth of cut, the alignment of the workpiece between passes. 2 skilled milling operators will produce parts that differ slightly from each other, and the same operator on different days will produce parts that differ from his own previous work. A broaching machine produces an identical part every time the ram strokes. The variability that human skill introduces into precision machining is removed from the equation. For an industrial process trying to produce thousands of interchangeable transmission components per month, this was not a minor advantage. It was the entire game. The third direction was the labor pool. A skilled milling operator required years of training and experience. A broaching machine operator required at minimum an afternoon's instruction. He clamped the workpiece in the fixture, pressed the cycle button, removed the finished part, and put another blank in. The skill resided in the tool, not the operator. For a wartime economy where every skilled metal worker was being absorbed into the army, this was the decisive factor. A broaching machine did not by itself win battles, but a factory full of broaching machines could produce in a single shift more precision-machined tank components than a factory full of milling machines could produce in a week. And across the millions of internal features that went into the American Armored Fighting Vehicle program, that advantage compounded into something the Germans could not match. There is one further detail worth pausing on because it explains why the broaching machine spread through American industry the way it did. The same machine, once installed, could be retooled to produce a different part by swapping out the broach. The structural investment, the hydraulic ram, the work-holding fixtures, the frame, stayed in place. Only the cutting tool itself changed. This meant that an American factory could, over the course of a single weekend, switch from producing splines for one component to producing keyways for another. The flexibility was at the level of the tooling, not the machine. For a wartime economy that had to absorb constant design changes and shifting production priorities, this was an enormous advantage. The machines stayed where they were. The broaches changed. By 1940, the city of Detroit and the surrounding region of southeastern Michigan had quietly become the center of the American machine tool industry, and Detroit alone was home to at least 9 major manufacturers of broaching equipment. This was not an accident. It was the accumulated industrial logic of 3 decades. Detroit had grown into a machine tool center for one simple reason. The automobile industry needed machine tools. The Ford Motor Company at Highland Park and then at River Rouge had built itself on standardized parts produced by purpose-built machinery. General Motors had followed, Chrysler had followed. Every car had thousands of precision-machined components, engine blocks, crankshafts, transmission gears, axle splines, and the only economical way to produce them at the scale the American automobile market demanded was to build specialized machine tools that could turn out those components in seconds rather than minutes. The Detroit machine tool ecosystem that emerged around this demand was dense and specialized. Footbert was making drilling and broaching machines in Cleveland. Warner and Swayze was making turret lathes. Bridgeport was making milling machines. American Broach, founded in 1919 at 408 West Washington in Ann Arbor, was building broaching machines for the Big Three automakers and their suppliers. By the late 1930s, American Broach employed around 500 workers and was running its plant around the clock to keep up with automotive demand. When the war came, this ecosystem pivoted. The same machine tool firms that had been building broaching machines for Chevrolet transmissions began building them for tank transmissions. The same engineers who knew how to design a broach tool for cutting internal splines in an automotive differential knew how to design a broach for cutting internal splines in a Sherman drive sprocket. The same workers who had been operating broaching machines on civilian production lines were now operating them on military production lines. The conversion happened, in many cases, within months of the contract being signed. There is a statistic that captures the result. In 1940, just before America's full entry into the war, 28% of the machine tools in use in American industry were less than 10 years old. By 1945, that figure had risen to 62%. The fraction of relatively new, modern machine tools in American factories more than doubled in 5 years. This was the greatest such change ever recorded in such a short period in any developed country for which data exist. Between 1929 and 1942, annual machine tool shipments in the United States went from 50,000 to 300,000. Over the course of the war, the United States produced 800,000 machine tools, more than any other nation, and emerged from the war as the largest machine tool producer on Earth. The Defense Plant Corporation, an arm of the federal government, underwrote 30% of the financing for this build-out, removing the financial risk that had paralyzed American machine tool builders after the previous war. Private industry shouldered the rest, helped by accelerated depreciation schedules and tax amortization policies that made the capital investment feasible. The result was a quiet, patient, methodical national reinvestment in metal cutting capacity, and broaching machines were a disproportionate share of that investment because broaching was the machine type that delivered the highest production rate per dollar invested for the kinds of precision internal features that armored vehicle manufacturing required. By 1942, when the Detroit Arsenal tank plant was reaching full production, the machine tools running inside it were largely products of factories within a 100-mile radius.
The supply chain was tight. The technical liaison between machine tool builders and tank builders was immediate. When a problem arose on the production line, the engineers who had designed the machine could be present within hours to fix it.
In a 2013 paper published in the Economic History Review, the economic historians Cristiano Restuccia and Adam Tooze published the result of a multi-year archival study of the machine tool stocks of Nazi Germany and the United States between 1929 and 1945. What they found by counting actual installed machines in actual factories across both economies was that the popular narrative of the war was wrong in some important ways and right in others. It was wrong in this sense. The two economies were not using fundamentally different categories of machine tools. Both Germany and the United States used lathes, mills, drills, grinders, presses, and broaching machines. Neither country was locked into a rigid technological paradigm. Both had been modernizing their metalworking capacity through the 1930s, and by 1945, Germany had largely converged on the United States in terms of which types of tools were in use. It was right in this sense. The two economies were using those same types of machines in very different ratios, and the difference in ratios was decisive. The single most striking number to emerge from the Restuccia and Tooze dataset was the ratio of broaching machines to metalworking workers. In the United States, the figure of broaching machines per worker was approximately 5 times higher than the same figure in Germany, 5-to-1. A worker on an American shop floor in 1942 was roughly 5 times as likely to be operating a broaching machine as his German counterpart in a Berlin or Stuttgart factory. This is the number that should have alarmed Berlin. It did not because no one in Berlin was looking at the right statistic. The reason this ratio mattered so much had nothing to do with the absolute number of machine tools. It had to do with what broaching machines were used for. Broaching is the technique that produces precision internal features at high volume with minimal labor input. It is the machine type that turns skilled work into unskilled work. A country that has 5 times more of these machines per worker than its enemy is a country that has, in effect, 5 times more precision machining throughput per available trained operator. Multiply that across the tens of thousands of internal features that go into a tank transmission, a turret race, an artillery breech mechanism, a vehicle suspension system, an aircraft engine reduction gear. The compounding effect is enormous. By the spring of 1943, the American war machine could produce precision machined steel components at a rate that the German war machine simply could not match. Not because German engineers were worse, but because German factories were configured around a different ratio of machine types, optimized for a peacetime economy that the war had violently changed. The Germans understood, in some general sense, that they had a machine tool problem. The German Strategic Bombing Survey's Tank Industry Report, compiled by American investigators after the war, recorded that as early as December 1942, the chairman of the Main Committee for Panzer Production had warned Hitler personally that achieving the Führer's stated production targets would require enlarged factory space, additional raw materials, and additional machine tools that simply were not available. Hitler had responded that the program was to be carried out whatever the cost. The cost turned out to be that the program was never fully carried out. The clearest illustration of what the machine tool gap actually meant on the ground comes from comparing two factories building their respective national premier medium tanks. Chrysler's Detroit Arsenal tank plant, building the M4 Sherman, and MAN's Nuremberg plant, building the Panther. The Detroit Arsenal tank plant occupied 113 acres in what is now Warren, Michigan. It was designed by Albert Kahn, the same architect who would later design Willow Run, and was the first manufacturing facility in the United States built specifically for the mass production of tanks. Chrysler signed the contract in August 1940 for 1,000 M3 medium tanks. The first M3 rolled off the line in April 1941, while the walls of the plant were still being completed. By December 1942, the plant was delivering 896 Sherman tanks per month, a wartime record that would stand for the rest of the war.
Across the full course of its World War II production run, Detroit Arsenal alone built about 22,000 tanks, roughly a quarter of the 89,568 tanks produced by the United States. Inside the plant, the production logic was direct. Hulls and turrets were welded by semi-skilled labor. Engines were assembled by sub-suppliers and dropped into the hulls, and the thousands of precision-machined components, transmission gears, drive sprocket splines, turret race rings, idler wheel bearings, suspension bogie components, were cut by specialized machine tools running at automotive industry speeds. Many of those tools were broaches. The internal splines on the drive sprockets and the gear teeth in the transmission were produced by broaching operations that took seconds each on machines that ran 24 hours a day, fed by workers who had been trained on the job in a matter of weeks. The Mann plant in Nuremberg building the Panther operated under different constraints. The Panther itself was a more sophisticated design than the Sherman, better armored, better armed, with a more elaborate transmission and a more complex suspension. Its production was authorized in 1942 with an initial target of 250 units per month at Mann. By January 1943, the target had been raised to 600 per month. The figure was never reached. Across the entire Mann production run, even with manufacturing expanded to Daimler-Benz, MAH, and other firms, total Panther production reached approximately 6,000 units between 1943 and 1945, less than a third of Sherman production at Detroit Arsenal alone.
The reasons for this gap have been studied in detail. The Mann's start of production was delayed, by Wikipedia's account drawing on contemporary German records, mainly because of a shortage of specialized machine tools needed for the machining of the hull. Allied bombing later destroyed key bottleneck facilities, particularly the Maybach engine plant, which was hit on the night of April 27, 1944, and halted Panther engine production for 5 months. But behind the bombing, behind the labor shortages, behind the constant design changes that Hitler personally demanded, there was a more fundamental problem. The German factories building the Panther were configured for a model of production that depended on skilled machinists and conventional machine tools. They did not have in sufficient quantity the broaching machines that would have allowed unskilled labor to produce the precision components at automotive scale. The Tiger I, manufactured at Henschel in Kassel, was an even more extreme case. The Kassel plant's highest monthly production goal was 95 units. It never produced more than 104 in a single month during the Tiger's 25-month production run. Total production, 1,347 Tigers. By comparison, the United States produced more Shermans in a single month at the peak of 1942 than Germany produced Tigers across the entire war. Each Tiger required, by post-war estimates that vary by source, roughly 140,000 to 150,000 man-hours of labor. Each Tiger II required 200,000 to 300,000. A Panther required 30,000 to 60,000 man-hours, depending on the factory and what subcontractor hours were included. A Sherman, by the Detroit Arsenal's own contemporary records, could be produced at substantially lower labor input per unit, and crucially at far less labor input per precision-machined internal feature, because the broaching machines were doing the work that German factories were still doing with skilled hand operations. This was not a difference in engineering skill. It was a difference in machine tool inventory. When the German tank industry attempted to expand its production capacity in 1943 and 1944, what it discovered was that the bottleneck could not be quickly closed. A broaching machine is not a thing that you can simply order and install. The machine itself has to be built. The tools have to be designed and manufactured to the specifications of the part being produced. Each broach is a custom cutting tool, often costing as much as a small house, taking weeks or months to produce in itself. The supporting infrastructure has to exist, the tool makers who can sharpen the broaches as they wear, the engineers who can design the fixtures and work holding, the supply chain that can keep the machines fed with steel blanks.
A factory that wants to convert from milling to broaching for a given component does not flip a switch. It rebuilds part of its production process from the ground up. The American advantage was not just that the broaching machines existed in American factories, it was that the entire ecosystem around the broaching machines existed. The tool makers, the broach designers, the maintenance machinists, the production engineers who had spent the 1920s and 1930s figuring out how to apply broaching to automotive production. When the war converted American auto plants into tank and aircraft plants, this ecosystem converted with them. The German equivalent did not exist at the same density. German machine tool makers had been excellent at building general-purpose precision tools, lathes, mills, grinders, that emphasized flexibility and skilled operation. American machine tool makers had specialized, through the 1930s, in production volume tools that emphasized throughput and unskilled operation. By 1942, those choices had compounded into incompatible industrial paradigms. There was a further problem on the German side that compounded the machine tool gap. The Wehrmacht's procurement philosophy had, since the mid-1930s, deliberately favored manufacturers who used flexible craft-style production methods over those who used hard tooling and assembly lines. The argument was that flexible production allowed for rapid engineering changes, and the German military preferred this because German weapons designs were constantly being revised. The Tiger received more than 250 engineering changes during its production run. On average, a Tiger leaving the factory differed from one built 6 units earlier on the line. This made the German tanks better in some ways. It also made them impossible to mass produce by American methods. Albert Speer, who took over German armaments production in 1942, understood the problem in general terms and tried to address it. He simplified weapon designs, he rationalized production, he pushed for longer runs of fewer variants. By his account, German tank production roughly tripled between 1942 and 1944, despite the constant Allied bombing of German industry. But the underlying machine tool gap could not be closed in the time available. To install 5 times more broaching machines per worker in German factories would have required years of capital investment, decades of accumulated tool-making expertise, and an industrial reorientation that the German economy did not have the time, the materials, or the political latitude to undertake during the war itself. What the Allied investigators found when they walked into captured German factories in 1945 was a manufacturing system that had been pushed to its absolute limit by talented engineers working with the wrong inventory of tools. The Germans had outstanding lathes, they had excellent grinding machines, they had the best optical instruments in the world. What they did not have in sufficient quantity was broaching machines, and that single gap had bled their tank production capacity throughout the entire war.
There is a long-standing argument, repeated in every popular account of the war, that the Sherman won because it was simpler, more reliable, and produced in greater numbers than its German counterparts. All of this is true as far as it goes, but it stops short of the actual mechanism. Greater numbers do not just happen. They are produced by specific industrial systems configured in specific ways that allow specific production rates. The Sherman's numerical advantage was not the result of patriotic enthusiasm or industrial spirit. It was the result of a specific decision made across hundreds of factories over a decade to standardize on machine tools that converted skilled work into unskilled work. The broaching machine was the centerpiece of that decision. Its presence in American factories, at 5 times the density per worker that German factories achieved, meant that an American Sherman plant could produce in one shift what a German Panther plant could produce in a week. The strategic consequences of this rippled outward. American armored divisions could be supplied at scale. American replacement vehicles could be sent forward to combat units as fast as they could be lost. The arithmetic of attrition, which had broken so many armies through history, ran in the American direction. A German panzer division that destroyed 4 Shermans for every Panther it lost was, on paper, winning a tactical victory. In strategic reality, it was losing, because 4 Shermans could be replaced in the time it took to replace 1 Panther. The math of the Broaching machine had inverted what looked like German combat superiority into German operational defeat. There is a quote from a German tank commander captured by American forces in 1944 that sums up the experience from the German side. Asked about the tactical balance with the Sherman, he is reported to have said that 1 Tiger was worth 10 Shermans, but the Americans always had 11. The number was probably an exaggeration, but the underlying intuition was correct. The Americans were producing tanks at a rate that the German industry could not match, and the gap was widening with every passing month. The kill ratio in individual tank engagements did not matter because the replacement ratio in the factories was rigged against the Germans before the engagements were even fought. What the German strategic bombing surveys investigators discovered when they finally walked through the captured Henschel plant in April 1945 was an industry that had been losing the production race not on the battlefield but on the shop floor, 3 years before its tanks ever met an enemy. The shop floor of an American tank plant in 1942 had been quietly determining who would win the engagements of 1944. The Americans had been doing this work, building the machine tools, training the operators, configuring the production lines, designing the broach tooling for tank components through the late 1930s, while the Wehrmacht was busy buying flexible craft production from manufacturers who could not, in the end, deliver volume. This is the unromantic truth at the bottom of every honest account of how the Western Front was won. It was not won by tanks. It was won by the factories that built the tanks. And inside those factories, more than any other single piece of equipment, it was won by the machine that the captured German engineers feared more than any Sherman they had ever fought. The machine that turned weeks of skilled labor into seconds of unskilled work. The Broaching machine, the unglamorous American answer to a problem that the German industry never fully understood. There is a tendency in popular military history to focus on what is visible, the tanks, the planes, the battleships, the famous generals, and to leave invisible the systems that produce them. The visible objects are dramatic. They photograph well. They appear in newsreels. They have names. The systems that built them are abstract. They live in factory inventories, machine tool manifests, ratios of installed equipment per worker. They do not photograph well. They do not appear in newsreels. The men who designed them and the women who operated them are mostly anonymous. This is a problem because the systems are where the war was actually decided. The American victory in the Industrial War of 1941 to 1945 was the cumulative effect of thousands of decisions made between 1929 and 1941, mostly by people whose names are not in the history books. The decision by Detroit machine tool firms in the 1920s to specialize in production volume tools, the decision by American Broach in 1919 to focus on broaching equipment for the automotive industry, the decision by Ford and General Motors and Chrysler to design production lines around standardized parts produced by purpose-built machinery, the decision by the Federal Defense Plant Corporation in 1940 to underwrite 30% of the financing for machine tool capacity expansion. The decision, never quite articulated as a single policy, but visible across hundreds of separate procurement actions, to bias American industrial investment toward tools that allowed unskilled labor to produce skilled work. None of those decisions at the time they were made looked like decisions about the Second World War. They looked like business decisions made for ordinary commercial reasons in an economy that was mostly trying to recover from the Great Depression. The fact that they would, in aggregate, determine the outcome of a global war fought 10 or 15 years later was not visible to the people making them. It is visible now only in retrospect, in the ratios of machine tools per worker that Restuccia and Tooze counted in the archives,
5 broaching machines for every one in Germany, multiplied across millions of precision-machined components, multiplied across thousands of armored fighting vehicles, multiplied across tactical engagements in Normandy and the Ardennes, and the Rhineland, where the Sherman crews outnumbered the Panther and Tiger crews they faced. Sherman crews knew by 1944 that their tanks were technically inferior to the German vehicles they were fighting. They wrote home about it. They complained to officers about it. They gave their tanks nicknames like Ronson, after the cigarette lighter whose advertising slogan was "Lights every time," because their armor would burn so reliably when hit. They were not under any illusion that their equipment was better than what they were facing. What they did have, and what their commanders increasingly took for granted, was that they were never alone. There were always more Shermans. There was always more ammunition. There were always more replacement vehicles arriving at the battalion supply point. Behind the men in the tanks, 3,000 miles away, were the factories. Behind the factories were the machine tools. And inside the machine tools, in numbers the German industry could not match, were the broaches, the long, multi-toothed cutting tools that quietly cut the gears, the splines, the keyways, the turret races, the internal contours that allowed unskilled American hands to produce skilled American tanks at a rate the world had never seen. The German factories feared those machines in the specific and accurate sense that they knew by 1943 that those machines were producing what they themselves could not produce. They feared them because the math of broaching was the math of the war, and the math, by then, was already decided. When you look at any major industrial competition today, semiconductors, batteries, aerospace, advanced materials, the lesson of the broaching machine is worth holding in mind. The decisive technologies are rarely the ones that make headlines. They are the ones that change the labor mathematics of an entire industry, quietly, over decades, in ways that only become visible when the next war or the next crisis arrives. Somewhere right now, in some unglamorous corner of some unglamorous industry, the equivalent of the 1940s broaching machine is being installed by the thousands. Whoever has more of them 20 years from now will probably win whatever the next contest turns out to be. If you found this story interesting, leave a comment below. What's a piece of industrial history you wish more people knew about? And if you know veterans or descendants who worked at the Detroit Arsenal, at American Broach, or at any of the other Arsenal of Democracy facilities, share their stories. The people who ran the machines are the ones who deserve to be remembered.